Welcome everyone to a LANSA webinar. Today's webinar is getting started with RPA on IBM. Thank you for taking your time and your busy schedule to join us today. My name is Jose Caso. I am the LANSA Product Marketing Manager. Please feel free to do questions in the Q&A option in the bottom of your screen. We will have a brief moment to answer your questions after the webinar has finished. Today, we're thrilled to have Patrick Fleming to share some of the powerful capabilities of the LANSA portfolio. Patrick is a professional services manager for LANSA. Okay, without any further introduction, over to you, Patrick.
Thank you, Jose, and thanks everybody for joining this webinar. So the topic for today is getting started with RPA on IBM. I'm a professional services manager based out of the LANSA Chicago office, and I've been working with customers over 20 years with modernization initiatives in terms of enterprise systems. And LANSA has a number of solutions that fit that market segment, and we'll talk about RPA in this meeting. All right, so the demand for applications is growing rapidly and will continue to grow. And we've seen in recent news with supply chain bottlenecks and people working from home that the application environment is actually getting more complex as well. So with our tool set and with most applications, you're really dealing with three aspects. One is you're modernizing legacy applications because you can't afford to rewrite them, but you need to use them and integrate with them in new ways. At the same time, you're building new applications to increase automation. So we've got the cloud and different applications that are out there that provide services that we can then use and integrate with, just to increase automation. And third, you've got the ongoing effort to build new products, to build better customer service applications, to build better websites, to provide more information to your users, to build better e-commerce applications and supply chain applications to streamline data through your system. Okay, so organizations look to companies like LANSA for help because we have a long track record of modernizing, extending IBM applications, and doing that faster, better, and at a lower cost when compared to traditional development approaches and standard development languages. One of the ways we can do this is through RPA, or Robotic Process Automation. All right, for some of you, RPA may be a new term, so let's quickly introduce it and explain what it is and why it's important. RPA is important to every organization because it allows you to reuse your existing applications in exciting new ways that will streamline business processes and reduce human effort, and all without having to change the original application running on the IBM. Currently, the technology is mostly employed in industries such as banking and finance, insurance, healthcare, and utilities. There are many cross-industry functional processes such as payrolls, onboarding of employees, accounts payable, order management, invoicing, and customer support, just to name a few. These are some of the best candidates for robotic process automation. Right, so RPA is on the rise. So RPA is gaining a lot of attention these days. As you can see, it is ranked as the third most anticipated technology over the next 18 months, according to a survey by APQC. Basically, any business process that involves computer-centric, rule-driven, high-volume clerical tasks is primed for robotic automation. Robotic process automation is most coherent when you consider it from the business user's perspective, not the IT perspective. To implement RPA, you don't need to turn the IT architecture on its head. What you need is a good evaluation of the processes involved in your organization and consistent mapping of how your employees interact with the system and how workflows are processed. So robotic process automation is not a standalone initiative. It actually integrates with other initiatives like analytics, data management, intelligent automation that you already see here. Right, RPA also delivers results. So it's really an architecture that's goal is to save money and reallocate employees to do more productive work. So it's gaining a lot of attention because it's successful and beneficial to an organization's bottom line. As you can see here, more than half of the companies that have implemented an RPA project said that it had met their expectations and delivered the ROI they were hoping to achieve. 21% said it was above their expectations, and almost 3% said their RPA project was far above their expectations. So RPA is really one stage of an evolution journey. The buzzword intelligent process automation, IPA for short, involves adding to RPA the capability to work with unstructured data, written natural language, such as voice, image and speech recognition, and to transform it into structured data that can be automated. Think of tools like AWS Textract that reads documents through OCR and converts that to text. There are text-to-speech applications. There's IBM Watson's AI capabilities. For any higher order or lower order automation, data needs to be optimized and standardized. Once you do this, robots can take it from there. So what you see on that diagram is the evolution from process-driven, where we can start with robotic desktop automation, moving on to robotic process automation. So it's still driven around the human is involved in the process, but as you get your data more under control and structured, the machine and the robot can then take over, learning as to how the process works, learning the exceptions just through trial and error, and then possibly moving on to artificial intelligence. So as you go through that evolution, there's going to be increased complexities and costs, but you'll be able to handle the volume. So in your journey, you've got to define your starting point. And over time, data will drive more of the robot activity. Okay, so if you're wondering if your 5250 applications can participate in RPA, the answer is definitely yes. With LANSA's modernization tools, any 5250 application, regardless of whether it's RPG, COBOL, or a LANSA 5250 application, can participate. Participating in RPA means you can streamline your most inefficient and error-prone processes while leveraging your existing applications to communicate across multiple systems, and all without changing a single line of code. And lastly, time after time, LANSA customers have achieved tremendous ROI with their RPA modernization projects, which deliver true business value. Right, and that's the goal, is this ROI objectives. So you can measure metrics like, what was my time saving in this process by average in this workflow process, and how much money did I save, and what measures can I measure, such as external customer satisfaction. Right, so let's talk about how LANSA's tools such as RAMP enables you to reuse existing applications. RAMP is LANSA's desktop automation tool. So think about a typical 5250 application. It's made up of a number of screens. So we like to categorize them as destinations. You can see those at the bottom. These are the screens where the user actually performs work. Or navigation screens, they're the ones you see at the top. They're the screens that take the user around the system so they can get to those screens where they do work. So an example of a navigation screen would be a menu or the sign-on screen. So in order to do order entry, I'd sign on, I'd go to my menu system, and I'd navigate through my menus to get to order entry. And that's the screen where I'd fill in the details like the customer number, the order number, and the parts and quantities. Okay, and this is what a ramp solution might look like. So obviously this would not be used by a robot, this would be used by a human. And it's actually a refaced, on the right-hand side, that's a refaced 5250 screen with all of the navigation hidden from the user. So all of the data you see on that screen with the address details came from a 5250 screen. And we could value add to that 5250 screen a picture of the employee and other information that was an extension of what the 5250 application actually did. So accessing the destination and going down that path between navigation, to navigate to the in and out of those destinations is sub-second. So it's going to be faster than any human could ever type. So the reason why people are interested in ramp solutions is they don't want to change the back-end 5250 application. They just want to improve the interface for users to that system and control the navigation of the screens. So the end user doesn't see any 5250 menus. They'll work with things that they understand, like a list of employees. So as you click on each employee, it's going to show me that employee details. And that end user isn't even aware that that data is being taken off a 5250 screen. So we don't need to rewrite the backend application. We don't need to necessarily build any new web services or modernize the backend if our interface is working through the 5250 screens. Okay, and that's the part of the screen that came from the 5250 screens itself. Right, and how did it do that? All right, it's actually a refaced 5250 screen with all of the navigation hidden from the user. When the user clicks on the tab, they'll see that screen with the picture of the employee. But how it actually got the information on the screen was that the ramp tool started up, it started a 5250 session, and it navigated through that navigation menu to get to that screen where employee details are shown, and was able to programmatically, through a script, programmatically read those fields off the screen and return them to the LANSA web page. And then on the LANSA web page, we could extend them by providing drop-downs, checkboxes, date pickers to actually improve how the user interacts with that screen, because 5250 screens are generally limited with those sorts of capabilities. Okay, so now we're moving on to the next stage of automation. Let's talk about more complex transactions. So if you think about it, many application processes are complex. For example, how do we bill a customer? Or what are the steps required to create an order? Or how do we receive truckloads of products into inventory? And this can be made more involved than just looking up a customer's details. It's not just on one screen, there's actually a transaction taking place. So these types of processes that involve interacting with several parts of an application or different applications, they could be browser applications or Windows applications or sourcing data from different websites, if not several applications. All right, quite often we hear users complain how it takes them 20 screens to complete an order, and even more if it's a complex order. These are prime examples of when we need some way of simplifying the process. So again, with RAMP, you can create a brand new screen that gathers all the information for a process. So this is a screen. As you can see, there's a number on the right-hand side. We have a dashboard, we have a graph, we've got information about the customer, and we've got other things that the customer is involved with. So you've got multiple screens here, all all available, to the user at once. So this is a screen not just based on one 5250 screen. And when you click the submit button, RAMP can call your existing multi-step process behind the scenes to create the transaction, passing in data from the new screen as keystrokes to execute the legacy application. So it will start the transaction, it will navigate through the order entry screens, for example, to then complete that order process and finish the transaction. So what you need to decide in this scenario is to do your order entry validation up front. So by the time the transaction starts and the robot takes over, all of the data is valid. So there are no surprises for the robot as it processes the data that's been picked from the controlling application. Right, so LANSA's RPA technology can be used outside of RAMP as well. LANSA has had modernization solutions and automated screen navigation for 15 years. And we are able to those technologies for full process modernization. So those areas, in terms of full process, allow us to RPA enable any 5250 application and to deal with erroneous and efficient processes. So RPA has to deal with error handling and unexpected results. And so we need to be able to read, well, when I hit this function key, I didn't go to the screen that I was expecting to. So can I recover from that scenario, or do I stop? And we'll want to make sure that the robot has some intelligence and can resolve that error if possible. All right, so we can also do RPA with LANSA applications or other applications, as we'll see later. So we can execute an existing application when you need to perform the transaction. So let's imagine you've got a very complex ERP system, and creating an order goes through a number of steps. And at the same time, you're trying to build a website, an e-commerce website to allow your external customers to do online ordering. Well, it might be difficult to call your existing create order program, but what if you could actually take the data from your e-commerce website, so when the user does the checkout, you'll be able to feed that information about what part numbers, what item numbers, what quantities, what the customer number is, what the order total is, feed that to the 5250 screens and let it create the order. So we're not calling an RPG program from our e-commerce website. We're starting up RPA, and RPA is going to use the data that I feed to it. It's going to navigate through those screens through the robot, and it's going to complete the transaction itself, just as if a human had done that work. And that's the real crux of RPA, is we're simulating what the human is doing and automating that. It's as part of our RPA journey. So there's a process that's taking place. We've captured the data from one system, and we're now feeding that data to the other system that performs that transaction. And we've got a way of knowing that that transaction is completed, and then feeding that data back to the controlling application. All right, and that's known as the RPA bot. Okay, so where do we fit in this RPA? There's lots of programming languages. So we could control the RPA from a .NET application or a Java application. We can also use RPA software. So in the industry, they're fairly well established. There are organizations or software called UiPath, has a robot.js SDK, which allows you to script JavaScript, which is our technology for controlling 5250 screens, and control that from the UiPath software itself. We can interface and be controlled by Automation Anywhere. Microsoft are now, they've got their own RPA software called Power Automate, and there's another one called Blue Prism. So in terms of how you want to work with RPA, one of your key questions is, have I already got RPA software across the enterprise that we're already using now? For example, UiPath. And can I work with UiPath and control 5250 applications? If you want to take that approach, yes, we can work with that through their JavaScript interfaces, for example. Or if you said, well, I've got an RPG application or a .NET application, maybe I've got a CRM like Microsoft Dynamics or Salesforce, and I want to show customer account inquiry. You can use RPA to then control the navigation to that screen and show it in your Salesforce screen or your CRM Dynamics screen. So there's lots of different scenarios of embedding automation. The key question is it attended or unattended? So attended means, and this is an RPA term, means is a human watching it and processing it. So if you've got a workflow process with a mortgage application and you're taking in an employee's the applicant's W-2 and maybe their driver's license, you're scanning those things, you're extracting the text, you're feeding it to those back-end systems that might do credit scoring. You've got a human watching the process because maybe it's workflow driven and needs to be routed to different people. But unattended, on the other hand, means it's totally automated. So that means that the human's only involved if there's an exception. So if you've got high volume processing, then you might want to see it move to that unattended state, which reduces the human involvement and can handle more processing time. So the big advantage of the robot is they're going to be working 24/7. So if you've got processes that run all day, run all night, never stop, and big loads, then unattended processing may be your target. So in terms of how LANSA works with RPA, it can be controlled by another application, or it can also control another application and also use bots. So the integration of RPA with on the IBM I with LANSA technologies is up to you. Right, so what I'm going to do next is show you how RPA can be implemented on IBM I. I'm going to demo a number of different use cases to show just how powerful RPA on IBM I can be. All right, so our RPA is a simple order entry process that will write to an order, header, and detail file. So there's an RPA via batch automation. And what we're going to use is email to deliver order details in batch mode. So imagine, my trading partner allows us to email them orders, or let's say you've got an ERP and some of your customers aren't that technology savvy and your ordering process is fairly simple, and they don't, have a lot of technology at their end. They can't do EDI, for example. You could have an interface where they could send you an email and it's got an attachment, a CSV attachment, for example, and then you could pick up that attachment and read it programmatically and then navigate through the order entry screens. So the key feature is that the RPA interface to the IBM I is the screens that the data entry user would normally use. We don't need to design an interface to the programs themselves. We can script the options that a user would take to perform the transactions and read and write the values off the screen to ensure that the transaction was entered successfully. All right, so then you've got another approach, which is real-time automation. And that's where your trading partner have got some technology in place. So they're able to send you orders through maybe an XML data format, or maybe a JSON format. So maybe their application can produce an order, let's say it's Shopify, where they can pull orders, and then you need to get those orders into your system. So the order format would be XML, it would have the order header information, it would have the order details information. And when that is sent to me, or to the LANSA technology, we'd read that XML file, we'd start up the 5250 session through the robot, and it would then navigate through the screens, pulling the data off the XML or JSON, and then mapping that to the screen. So in approach 1, we're reading the email itself and doing the mapping. In approach 2, we're reading the XML and doing the mapping. And now we've got the third scenario. Imagine you've built an e-commerce website or a simple order entry website. We've now got a situation where we're taking the information through a web interface, and then when the user clicks the button to create that order, then we can process that order. And the advantage there is we can do a bit more validation. Okay, so this allows a more interactive way of interfacing with the system. So we can do things like editing an order as well. So approach 1's probably very simple. All the user can do is create new orders. You know, whereas as you get through this evolution of approach 3, this is more interactive. Okay, let's talk about the steps to create an order, because this is what the robot is actually having to go through. Right, so the user would connect and log in. It needs to start a 5250 session. And it then interrogates the values of the screen identifiers and the field values. So when I sign in, I get my initial user menu. I'll interrogate the values of the screen identifiers and the field values. I need a way of not knowing what menu this is. So the LANSA technology allows us to identify screens and name them, so then the robot can identify where it is. Think of very similar to Google Maps. You know, you just like on Google Maps, you'll look at street signs. Well, here we've got identifiers for the screen, and it knows that this screen's a menu. And then on that screen, I can set values for fields on the screen. So in this situation, we're running the command line. You know, we type in that command to get to our menu. Okay, so what I'll do is I'll just sign on and then simulate that experience. Okay, so there's our main menu. All right, so on the order entry menu, we'll take option 1, all right, and that's got a number of menu options. I'll now take, if I'm doing order entry, I'll take option 1 again, and there I'm in order entry. And that's where the robot would be reading the values, whether it was an email, XML, or a web page. It would read the values passed across from the controlling application and fill in the batch number, the order number, the customer number, the order date. And then it would move on to this sub-file or browse list, you know, and fill in the details on each line. It would then hit enter. It would test whether there are any validation errors, and then it would be ready to enter the next order, right? And for each time that request is made, there would be another connection session. So the robot, at the end of the process, logs off. So it doesn't leave the user at a screen, it automates the whole process. So each time the user starts a transaction, it goes through these steps again and again. So the robot, just like any robot, only knows based on what you've told it. Okay, so let's kind of deep dive into the actual scripting language. You know, what are these LANSA tools and how do we feed those instructions to the robot? Okay, so the automated script here follows the same flow as the user, and there are 4 discrete steps. So the robot reads this CSV file. So for every transaction cycle, let's call this order entry, would have a .csv. This CSV would live on the IBM I. So it would only be available to the robot itself. And what you're seeing here are the steps. So these are the shortcuts the robot to 4 different steps. So here's where we connect. So this is our scripting language. We connect to the system. So there'll be settings for, you know, what port I'm connecting on, and what user I'm logging in as. So we'll having now connected, we'll now execute and tell it to go to order entry. How does it go to order entry? It goes to the command line. So you can see the line number, line 20, column 7. Type in this command on the command line, just like you saw me do. All right, hit enter. So this is the error handling. What if I do if there's an error? So you can define error steps in the CSV, though if you've got a lot of conditional processing, I'll show you with approach 3 how we can handle it, with a bit more control. But what will happen is it'll type in that command, it'll go to the next screen, it'll take option 1, it'll go to the next screen, it'll take option 1. You saw me go through 2 menus. All right, and then it's going to pause. It's going to wait for more instructions. Okay, so now I'm telling it to now go to the header part of the screen. So we saw on that order entry, there was the header part, and then there was the subfile down below. So we've got the order header information with the order number, the batch number, the customer number, the order date. So what we're doing is setting those values. So line 3, line 4, line 5, line 6, that's where they are on the screen. And these are the values that have been passed in. So if these came in through an email, I'm using our technology to read that email and to extract those parts of the email format to map to those fields. All right, and notice there how there's no enter. So I'm setting those fields on the header. And now what I'm going to do is loop through my order details. So this is a loop, I'm going through each line because I need to put one row, of each part number, quantity, price on each line of the subfile. So I'm going to loop through those and index and run this part of it. So the TX execute is the point at which I'm doing something with the screen. And the screen is pausing, waiting for more instructions. So I'm feeding that part to the screen. And now I'm saying send, hit the enter key. And that's going to validate what the screen's going to do. Now, TS capture allows me to see what the screen looks like. So obviously for debugging purposes, you want to know if something went wrong, well, what screen was it looking at? So TS capture is just like a debugging step or a logging step that allows me to see what the screen looked like. I want that for 2 reasons. One reason is for debugging, so if something went wrong, I can see what the robot was looking like. But the other reason is line 22. A lot of RPG or 5250 applications tell me that something worked by showing a message on line 22, either an error message or a success message. So TS capture allows us to read things off the screen as well. Right, and then we send that data to the screen and then we sign off. So we're done with this order. If the order was successful, then we want to basically sign off. And sign off means hitting function key 3 and then taking the option sign off. And obviously different users will have different menus. So this is a very simple example of that. But you can see how the robot was able to take its instructions through this CSV, and the script was able to nominate which set of instructions it was going to execute based on where it was. Okay, so having seen how the script works, let's actually run through this with our LANSA software. So this is a very simple example, RPA through batch automation. We've got RPA can support multiple delivery options. Let's look at the simplest as an email attachment. I could have also FTP'd a file, so on the IBM I could be picking up these files off an FTP server. Or I could be monitoring a network folder. So if this is an internal application, there could be a folder on the network that people are copying these orders to, or these CSVs to, and I could monitor that folder. So in this example, I'll have the IBM job scheduler handle the processing. So you can see that it's actually totally automated. So I've got this email. So here's an example of what the email looks like in our email simulator. So we've got batch number, customer number, order date. Obviously it has to be formatted because we're parsing this out, and we've got our CSV attachment that's got those order lines. Right, so what I'm going to do is go to our job scheduler. Whoops, get that on the right line. And spell my So those of you that have an IBM background are used to the job scheduler, and that's where I can schedule jobs or control when they run. So this might be a scenario, again, if it's FTP based or email based, I'm running this every 5 minutes or 15 minutes. Okay, so I'm just going to run that. And then I'm going to check my log. Okay, so this is our software called LANSA Composer that runs these processes. And you can see it's running right now. So it's active, the robot's doing its work. I'll just wait for it to finish, although I can see what it's doing when it's running. All right, it's finished. And let's look at that log. So I showed you on the previous slide the steps that it was performing. We can actually see what it did, with that particular email. Okay, so it picked up the email from that POP server. It took the subject line, it picked up the attachment, and now what it was doing was parsing out that data for the batch number and the order number and the and other values that were there. So we can see those values. And now it's going through the loops and mapping those values. So when it starts the robot, it can have the values. And now it's got the CSV attachment. And now, having got the attachment and the email body, it can now work through the screens. Okay, so you can see I'm capturing the screen image for debugging purposes. That's where I first arrived at the screen. Okay, and now you can see I'm feeding the header information. That was the TS execute step that I wanted it to perform first. Okay, and now I'm looping through the CSV. Okay, there's line 1 of the order. There's line 2 of the order. There's line 3 of the order. All right, and there's line 4 of the order. All right, and now I've hit enter. The robot's a bit out of control on my screen. I've hit enter. I've read that message to say, all right, the order was saved, and now I can disconnect. So I can notify whoever needs to be notified that processing is complete and that order is complete. And if I look at my database, I'll just run that command. Just add that library. And there's the order. So we took in from the email and put in these values, and the system calculated that line value. So the RPG program at the back end did whatever business logic it needed to perform. The email, all it provided was the data. Right, so that's it. That's example 1. So I'll just minimize that and minimize that. So that's a very simple interface. So this would be great for testers. And that's the other nice thing about RPA is we can load test this. Because we've automated the processing steps, we can load test as many orders as we need to and test all of the exceptions and make sure that the robot is handling everything correctly. Well, let's look at another example. All right, so here we could send a formatted request. So a lot of interfaces these days come in through the web, HTTP, HTTPS, AS2. There's a lot of application to application interfaces that are based on sending and receiving data. So it requires that the response come back as soon as possible. The email's convenient, but as a user sending an email, I've got to keep checking my emails that I've submitted to make sure that the order was confirmed. And in the example that I just did, that was probably the next step in the process, was to send a confirmation email to that person that sent the email saying that their order was accepted. So this could be a web service. So there's lots of different interfaces, and there's a lot of modernization projects happening now where the interface to the IBM I is now being exposed as REST web services, for example. The important thing is the response is immediate and the response is formatted. The disadvantage with the email format is that it's unformatted. If somebody did a spelling error, in it, obviously there'd be problems with me reading that email programmatically. So this is appropriate for high volumes. You know, it's where the trading partner's got some technology in place. And because it happens so fast, to show you what happened, you know, I'm going to go into LANSA Composer and show a log, just like I did with the email, that contains each detailed step. So the XML in this case will be mapped into the order header and line values, and then mapped to the screen values, and then the user will, the robot will hit enter. Okay, so what I'm going to do is use I'll just bring this over here. Okay, software called Postman, and this is posting. This is our IBMI, and we're posting this XML content to the IBMI. So it's still got the same elements as you saw in the email body. Instead of the CSV, we've got the order details as multiple line numbers. Okay, and just as a reminder, I'm going to just change that to all two so I can distinguish that particular order from the previous one I did through email. I'm going to click send. All right, so what it's doing now is it's posting that XML document to the IBMI. The web server on the IBMI is processing that. It's passing it over to LANSA Composer, which is then reading the XML, mapping it to the values that the robot needs, and we can see that it came back okay. If I then go back and look at my log, we can see it took 15 seconds, thereabouts. Okay, whereas the email one took 20 seconds because picking up the email, extracting it took a bit longer. But the advantage for the other application versus email is that it's totally programmatic. Okay, so again, if I expand all, we can see that it went through the same steps. You know, it went through the screens, fed the screens with the data, okay, for each of those line numbers. And if I run this query again, we'll see those orders come in. So that was the email one, and this was the XML one. All right, let's move on to the next one. We've got programmatic automation. So this is the scenario. I've got a web application, and this is useful where the screen flow is less predictable and more conditional. So there might be scenarios where, because the user's interfacing with the data directly, they might put in invalid part numbers. They might put in invalid customer number. So in this case, there's no CSV instruction set. It's more programmatic. So it's controlled screen by screen, because if there's an error, I need to capture that error, you know, not feed that directly to the robot. So let's add an order. So I'll just go to my web applications, or my web pages. And this is the web page that we've built for the demonstration. So we can, and this is built using LANSA's web technology, VL Web, low code. All right, so I've got web batch. Right, I'll put in the order number. I'll put in a customer number, and I'll leave the date. Okay, and I'll call this part 1. And list price is $5, and part 2. And line quantity is 4, price $10, and part 3. And 10 and 50. Right, and I'm now going to click save. So nothing's been sent to the robot yet. So I'd be able to do validations at this side. So if I blank that out and click save, it's going to validate this. You know, so I don't want the robot getting data that's invalid. Right, so I'll click save. And what's happening now is it's starting up the connection. It's done the navigation. You can see how quick that was. Well, what I can now do is change this. So not only is it parts entry, I could then append or change my batch number and then resave that. And it's then going to go into edit mode and then save that order. So save that update. So if I went to my screen again, we can see, that it's changed. So it's not just an order entry mode now, it's actually allowing me to edit that order because the web user interface is a lot more powerful. And in addition to that, in a web interface, there might be other capabilities that I need to allow through a web interface. So that might run a report, and this one clears the data. So if I want to run this test again, at this point, I've just removed all my records. So they're empty in the header and detail. So these were 3 examples of how to interface with my RPA technology from LANSA. All right, and there was no CSV instruction set. And if we wanted to actually look at what the programmatic interface is looking like, we've got our software called LANSA Integrator. An integrator has a service that allows me to interface with screens programmatically. So if we look at this print one, for example, it's probably the simplest. Here's our integrator log. And you can see it's doing the same things. It's loading the service, it's connecting, and it's running the screens. So it's typing in on the command line, that command. So you can see it's programmatic and just running the command. So here it took option 3, on that screen, okay, to do that print, and it ran the report. And on the other ones, we can see we've done a write. That's where we've created the order. So it allows me a bit more programmatic. Unlike the CSV, which had certain events, I can write and read screens, read and write from screens, and deal with more exception scenarios. And you could see it was a bit faster as well, compared with the CSV technique. All right, so if you're an RPG developer, you don't have LANSA at all, you can also use that interface, that programmatic interface from RPG. And there's an example of a call out. So, and if you're gone down the road of building REST services, you could plug in that programmatic interface into your REST services as well. So each of the approaches shown use LANSA software for the RPA interface. RPG programs or COBOL programs or .NET programs, PHP can also be used as an RPA client to control those 5250 screen flows. Right, so RPA is here to stay, and it is on a continuum. There is an evolution here that's taking place. So if we look at surveys, the payback of RPA is measured as improved compliance, and that's why banking, insurance, government are at the forefront of RPA initiatives. They've got big volumes of data to process. With COVID and the great resignation, as they call it, we've got less people. Those people are now, in some cases, working from home or working remotely. So teamwork becomes more important. So the things you can automate, that would actually improve that productivity and improve compliance. Human error is still human error. Certainly robots can create errors, but at least they can be trapped and tracked. And ultimately improve productivity, making people more productive and at the same time reducing cost. Right, and over time, 53% of respondents to this survey have already started their journey, and that will increase to 72%. Right, so if you're wondering how businesses are using RPA, the answer is in a variety of ways. Eliminating repetitive tasks that employees could complete 50 to 60 times a day. So if you're in the manufacturing distribution business, you're moving your shipment data to your shippers, you're pulling in customer orders and processing them, you're processing the bill of lading. Well, can those processes be streamlined so they're performed together rather than discretely by different people working in different applications. Right, eliminate or do periodic report generation, manual data entry and data analysis. Right, so if you're feeding data to a data warehouse or a data lake, can RPA automate that interface as well? Right, leveraging ERP and other lines of business applications to transact across systems. So you might be doing EDI, and you're getting your EDI orders, your 850s into your EDI staging tables, but somebody's rekeying that into your ERP system, or maybe the interface to the ERP is not as good as it could be. Well, RPA could automate the post-EDI processing and get all the things, all the steps that need to be done to get that order into your ERP system. Right, consistently converting data into different file formats and graphical outputs. And I'm betting everybody's got that challenge. The data's in this format in this system, and it needs to get translated into another format for that system. And we've got our LANSA Composer software that's great at doing this. Where RPA fits in is it goes that last mile, because a 5250 interface isn't naturally going to read an XML file or JSON. So we've got to basically be able to read the JSON or the XML format or the text format and then map that to the screens. And that's where LANSA's RPA technology kicks in. And therefore, if you're not having to rewrite the back end, your time to market is within a few weeks. So you may see RPA as a tactical solution. You're on the journey of building REST APIs for all of your back-end ERP transactions, but that's a multi-year project. You could get there sooner and interface with RPA. And even then, you may say, well, I need a testing tool. So you could consider RPA as your load testing tool as well, as an alternative to Selenium and the other test software. All right, so LANSA's IBM development and modernization allows all of those things. So if your project initiatives are part of digital transformation, addressing the skills gap, taking and leveraging low code and quick to build solutions, then we've got solutions for you. There's a great case study on the LANSA website for Greens. And this was a customer that had built an e-commerce website through Magento, but they didn't have an easy to interface with ERP system. It was quite old, was legacy, and they needed to go quick to market. And our RPA software allowed them to pull those orders that were coming in through their e-commerce website and map them to the back end and make sure that they were valid. And on our website, we've got 150 named case studies with examples like Stratec, who use LANSA modernization to improve their order picking process, and a lot of others as well. Okay, so you can try RPA for yourself. So we've got two software solutions that fit into the different interfaces. There's Axes, which is our tool for interfacing with 5250 screens, and you can try that for free. So it's got a JavaScript library that allow you to programmatically control the screens. And the interfaces that you saw of the three approaches that I used are using the Axes software to actually control those screens through JavaScript. And we've got LANSA Composer, and I used LANSA Composer in method 1 and method 2 to do that business process automation. So LANSA Composer was able to read the email, extract the CSV and orchestrate that process of starting the 5250 screen flow. Okay, so that's it for the slides. So back to you, Jose, for any questions.
Thank you very much. I think we really run out of time, and perhaps we can do some. We'll answer a pair of questions that the audience might have.
Okay.
Let's see. So here's the first one. You remember you can always type your questions in the box below your screen. So I have one here. It says, for those using an API, which software are you using?
Okay, so that was method 3. And in that scenario, I used LANSA Integrator. So I don't know if you're a LANSA customer currently, but if you've got LANSA Integrator, you can use the Axis TS service. So that's what I would recommend you use with your API. If you already got an interface that you want to control RPA from. Go ahead, Jose.
Okay, we have another question is, what kind of industries will be impacted by RPA the most?
Okay, I think those industries that see their competitive advantage as reducing cost and improving transaction flow. So already we've got banks like Chase Bank, and I think Wells Fargo have got major RPA initiatives where they've got target cost savings to make. So the CEOs have set a cost saving directive, and then the RPA groups, the business analysts within the banking and insurance, are working to get those RPA initiatives in place. And the key part there is you're leveraging your existing technologies. So we're working with a customer that was doing mortgage approvals, and they were using AWS Textract to read the W-2s and the driver licenses, scanning those through OCR, and then feeding that data into a process to do mortgage approvals, through RPA. So I think insurance, government, and banking are going to be the leading drivers of RPA.
Okay, great. So we have other questions, but I guess it'll be best if we can do it offline. If you can please send your emails. Can you please share your email?
Yep.
Patrick?
There's my email address.
Yes, because we're running out of time, and I guess all the ones that were typed here, we will get back to you through email. But again, well, thank you very much for attending to this webinar, getting started with RPA on IBM I. Again, Patrick, I would like to thank you for demonstrating the LANSA portfolio capabilities. Patrick is a professional services manager, and well, we hope you enjoyed this webinar, and that this webinar will inspire you to explore new possibilities with LANSA. In case you joined late, we're going to soon be sharing the recording of the webinar. In the meantime, if you have any questions, please don't hesitate to contact us at LANSA at info@lansa.com, or you can always reach out to Patrick, that he's showing his email right now. This concludes today's webinar. Thank you very much. Thank you very much.